To summarize what we have from the previous video, we used the minimize function in Python to find the smallest mean square error among all the lines. So minimize the mean square error among all the lines that we find the regression line. So we can either say that's the best fit line or least square line or the regression line. So in the 31 lecture, so here we have our RMFE. We define that in a function. So we apply from the minimize function. We pass in the function name. So according to the function name you pass, depends on how many input variable they have. So they will return either one single value or multiple value in an array. So that's why here we can see the slope and intercept will have the smallest mean square. So then you can plug in back to this mean square function again. So then we can see this line did have much smaller mean square error than the other lines. Okay, so that's finish up our least square line from the previous lecture. So let's continue with our lecture for today. So we have our procedure for this lecture. So what is procedures? So procedure actually is to evaluate our errors. So procedures is error in the regression estimate. So mostly we say that's for the regression line. So we try to get all the error in all the different points. So one procedure is corresponding to each point according to your observed data. So you have X and Y. So then, of course, we have our regression line. So that's why we can plug in our input X to get our estimate Y. So then the difference between our estimate Y and our observed Y, so that will be our residual. So that's why you can see here is the definition for residual, but they all mean the same thing. So they can equal to the observed Y minus the regression estimate of Y. So remember, did you see this one actually is the definition, similar to our definition earlier for the error. Just the error, we say that's the estimate minus the observed data. Okay, so the residual equal to the observed Y minus the regression estimate of Y. And we can say that's observed Y minus the height of the regression line at X. Right, so of course, you have your X, observed X, right? You plug into your regression line. So that's how we get our regression estimate of Y. On the other hand, that will be the vertical distance between the point and the baseline. So we will see that later in our residual plot. That will be easier for you to understand. That's our lecture 32 demo file. Okay, so of course we have our library to be included. And also here again, you can see we do have few function we need. So that we already see that before. So like how to convert to the standard unit, how to find the correlation according to the table you provide to data attribute. So then we can find the slope for the regression line. Then we can find the intercept. So the last one actually we add for this lecture is for, we call the fitted values. So this fitted value actually is, we already have our, so you have your table, then you have your X, Y, the two attribute. So then we plug into our slope and intercept function. We got that regression line. So then we just returned that all the estimate Y. So you can see here, so Y equal to mx plus b. So A is the slope. So we go through all the input X. So then of course the fitted values, they will return an array contain all the fitted, all the estimate Y. So that's the residual part. That's how we will apply all those functions to add the residual in our table. So we're still using our demographics table we have from the previous lecture. So you do have the college percentage and the median income. So here that will be still we will have our X and Y. Okay, so that's our X is our college percentage. Then we will have the Y is the median. Okay, so here that's define the residual. So what is residual? Like earlier we told you, right? The residual definition is the observed Y minus the estimate Y. So that's why the residual, we need to find our prediction. So that will be your the X plugging into your regression line. So that's how we get our fitted value. Okay, so that's we put on your table and XY. So then plug into your fitted value function that will return you an array. This array contains all the estimated Y. So then using your original Y minus your prediction Y, so that will be the residual. So that's our definition for residual. Okay, so after we have that, so that's add into our original table, demographics. So our demographics, we still have our the college percent and the median income. Okay, but here we add one more column, that's the fitted value. So this fitted value is came from our fitted value function. Okay, so then residual, we just plug in our residual function. Okay, so that's why you can see here. So then originally we only have these two columns. So that's our Y and our X. So this our fitted value is our estimate, the median income. So the residual actually, yeah, we can expect that the residual can be positive, can be negative. So that's why you can see the most they have negative at the beginning. So, but here you see we have more than 400 rows. So after we have those data, yeah, of course, we can put that into our scatter plot. So let me make that a little smaller. Yeah, actually, I cannot have this window a little smaller, but let me show you again. So this scatter plot, since we have the residual now, so we still have our, the dark blue color is our scatter. That's the original data. Okay, so then we have the yellow one is the fitted value. So on the other hand, it's like our regression line. Okay, so then we make our residual is the blue. Okay, so then you can see here. Okay, so that's why the residual, like earlier we say, right? The residual is the observed Y minus your estimate Y. Or we can say the vertical distance between the observed Y and estimate Y. Okay, so that's why you can see here. So this one, so that's why you can, this one positive, possible is this one. Okay. So that's all our residual. Okay, so one thing is, I also want you to see from this graph, we put that all together, it's a little difficult to see. Okay, but one thing is, we can see here is the original scatter. Okay, then we have our residual. So that's put separately. Okay, so this, then we just redo our graphic. Okay, so we make our graphic, actually we make two. Okay, so we separate the scatter plot from the original data and the regression line and the residual. Okay, the good thing, they have both good and bad. So earlier, if we only put in one graph, so you can easily to see the X we have. So that's what we call the residual is the distance between the observed Y minus the estimate. Okay, but they see they have the same X. So that's easier to see. So then you can see here, yeah, the residual, we have some of that they are 0. That means your estimate is exact as your observed Y. But some of them, they are positive. Some of them, they are negative. Okay, so then, yeah, you put together, but here is a little, we need to make our graph a little bigger. But then we can also separate that. But to separate that, one thing, Good thing is we can see the distribution for each one clearly, but the X line, they may not on the same vertical line. Okay, so one thing is, we just see here, what did you observe for this residual? So this one actually we call that the residual plot. Okay, so according to your X, so then we put, scatter our residual value. Okay, pause the video, think about what you observe here. So actually you can see here, like earlier we say, you have your residual, they have, some of that they are close to 0. Then they have positive, they have negative. But the pattern we see here, the positive side and negative side, they are kind of even. Okay, so you see when the X less than 20%, okay, so they have some positive, they have some negative. Okay, so then when we become bigger, so they still have some positive, some negative, but the range will be a little wider. Okay, so the same as the 60. Okay, but at least they are kind of very symmetrically. And also the residual, actually all you add them together, they should be equal to 0. Yeah, because we even out. Okay, so that's one example. We see the other example, the residual plot. So this one actually we used that before. Remember we have the heights. We have parents' height example before. So we're using the middle on the average of parents' height. Then we try to find the children height. So that's our scatter plot. And this yellow line is our regression line. So then if we try to plot our residuals, so then you can see here. Okay. So then you can see the same thing. The residual is the distance between your observed Y and your estimate Y. Okay, so then if we focus on the residual plot, they are the same. They are kind of very even out. Okay, so you have some residual is 0. Then for each region, they kind of have some positive, some negative. But the distribution kind of very similar for the positive and negative. Okay, so what we will find out from the residual plot. So what the residual plots for? So that's actually used to diagnose our regression line. So we call the regression diagnostic. So we see one more example. That's we have the table for the dugongs. So dugong is very cute animal. So we have a data. We have a dugong data. Okay, so they contain, here we only have about 27 data. So this data we have 2 attributes. One is the length, one is the age. So kind of we want to know, according to the length of the dugong, can we estimate their age? So then we have our scatter plot. Okay, so from this scatter plot, you can see, it kind of is the regression line, but it is. So that's fine. We just continue to see, like we have before, right? Once we have the table, we make the scatter plot. So then we try to find the correlation. Also, the correlation is about the 0.83. Okay, so then we make our regression line with our residual. Okay, so here is our fitted line. Okay, so according to the fitted lines with our observed data, that's our residual plot. So observe this residual plot. What did you see they are different from before? Yeah, so if you pause the video and discuss with your classmates, so we can see this residual plot kind of very different from before, right? Why? We do have some 0, but then you can see less than 2, maybe that's 2 feet, maybe smaller, but less than 2. Okay, they are all positive residual. So on the other hand, that's we are underestimate. So then between 2 to 2.6, most they are overestimate. Okay, so then we have a lot is underestimate as well. Okay. So according to this residual plot, we kind of can say, because we say the residual, they will have the average will be 0. Okay, so actually our residual plot, they can be positive and negative, but we really want them to be a little balanced or symmetric. But you can see this one, they are not. They have some region have a lot of positive and some region have a lot of negative. So if we have this kind of situation happen, that's mean the regression line maybe is not the best regression we should fit for our data. So you can see from the original data, so they are kind of not actually very straight line, right? So maybe quadratic equation will be better fit. Okay, so we will stop here. So see, check some regression on the residual plot we have and observe that. So in the next video, we will talk about more.